Okay, so we're going to look at compound angles. So the first thing then are the formulas for compound angles. A compound angle just means we're adding two angles together. Okay, so we have a formula for sine, for cos, and for tan. Now these are all in your formula book, so you just need to be able to use them. So the sine of A plus or minus B equals sine A cos B plus or minus cos A sine B. Cos of A plus or minus B equals cos A cos B minus plus sine A sine B. So that means if we have a plus in this bracket, we'll have a minus here. If we have a minus in this bracket, we'll have a plus here. So the signs swap around. And the last one for tan, we have tan A plus or minus tan B over 1 minus or plus tan A tan B. Okay, so you can see if there's a plus here, there'll be a plus in the top and a minus in the bottom. If there's a minus here, there'll be a minus in the top on the opposite sign and a plus on the bottom. Okay, so we'll have a look at a few different examples. So our first one, express the following as sine alpha, where alpha is acute. So our first one then is sine 20 cos 40 plus cos 20 sine 40. So this one goes sine, cos, cosine, so it's going to be our sine compound angle. And this is our A, 20, and our B is 40, so we can write that as 20 plus 40, which obviously we can write then as sine 60. Okay, so our next one, sine 72 cos 63 plus cos 72 sine 63. Again, we have sine, cos, cosine. So it's going to be the sine one. This time it's 72 plus 63, which gives us sine of 135. Now the question asked to write it in as sine alpha, where alpha is acute. Obviously 135 is not acute, so this is where you have to use everything that you know about angles. So we know that if we have an angle of 135, it's the same as the sine of an angle of 45. So sine of 135 is the same thing as sine 45. And our next one then, cos 27 cos 12 minus sine 27 sine 12. So we know this is it's cos, cosine, sine. So looking at our formulas, it's going to be the cos one, cos, cosine, sine. So where we have a plus here, we have a minus here. Where we have a plus here, we have a minus here. So we have a minus here, so it's going to be cos of 27 plus 12. So that's the cos of 39. Now, again, using what you know about angles, the question asks for sine alpha, not cos, but we know that the cos of an angle is the same thing as the sine of 90 minus that angle. So we know that, for example, cos 30 and sine 60 are the same things. Okay, so we can write this as the sine of 90 minus 39, which is the sine of 51. Okay, our next ones then are simplifying. So we're simplifying the following. So our first one is tan 3 theta plus tan 7 theta over 1 minus tan 3 theta tan 7 theta. So it's obviously the tan formula that we're looking for. So we'll have to remember now that if it's plus here, it's going to be a plus in the bracket and a minus below. Okay, so we can write this then as the tan of 3 theta plus 7 theta. So we can write that as the tan of 10 theta. Second one then, sine 6a cos b minus cos 6a sine b. So it's sine, cos, cosine, so you know it's going to be the sine one. Whatever in sine, whatever the sine is here will be the same as the one in the brackets. So we get the sine of 6a minus b, and we can't simplify that anymore. Okay, next one then. Find in exact form the value of tan 135. Now, the great thing about these questions, we can check the answer in a calculator. Now your calculator is that math mode, it does this for you, but it could still come up on the exam and you have to show the working out. So we can write 135 as 180 minus 45 and then put it into our compound angle formula. So that's tan 180 minus tan 45 over 1 plus tan 180 tan 45. And you should be using the angles 45, 30, 60, 90, 180 and so on, the ones that you're expected to know. So tan of 180 is 0 and tan of 45 is 1. So putting that in, we get 0 minus 1 on the top. The tan of 180 is 0, so this whole thing becomes 0, so it's just 1 on the bottom. So minus 1 divided by 1 gives us 1. So slightly harder one then, cos of 165. So I'm going to write that first of all as the cos of 180 minus 15 and expand that out. So that's going to be cos 180 cos 15. Remember, when there's a minus here with cos, it's a plus when you expand it out. And that's sine 180 sine 15. So the cos of 180 is minus 1, so that becomes minus the cos of 15. And the sine of 180 is 0, so that disappears. Now I'm going to write 15 then as 45 minus 30, and I'm going to keep the minus on the outside. So expanding that out, that's going to be cos 45 cos 30 plus sine 45 sine 30. So that's root 2 over 2. Cos 30 is root 3 over 2. Sine 45 is root 2 over 2. And sine 30 is 1 over 2. So this gives you root 6 over 4, and this gives you root 2 over 4. So just combining all that together, we get minus root 6 minus root 2 all over 4. Okay, and our next one then, cosec of 75. Well, we've got no compound angle for cosec, so we'll have to do sine. So the first thing we're going to do is find sine of 75. So sine 75, we can write that as the sine of 45 plus 30. So expanding that out, that's sine 45 cos 30 plus cos 45 sine 30. So the sine of 45 is root 2 over 2, cos 30 is root 3 over 2, cos 45 is root 2 over 2, and sine 30 is a half. So that becomes root 6 over 4 plus root 2 over 4, or root 6 plus root 2 all over 4. So that's what sine 75 is. Cosec then is the reciprocal of it. So cosec 75 is 4 over root 6 plus root 2. Now you would never leave this as an exact value. You need to rationalise the denominator. So either you can multiply top and bottom by root 6 minus root 2, or you can stick it into your calculator and hit equals and it'll rationalise for you, and you get root 6 minus root 2. Okay, so our next type then, find the maximum value of each of the following and the smallest positive value of theta where it occurs. We've got sine theta cos 20 minus cos theta sine 20. So it's sine cos cosine, so that's the sine one. And that's going to be theta minus 20. So the maximum value of the sine of anything is going to be 1, and that's going to occur when this equals 1. Okay, so inverse sine of 1 is 90. So a value of 110 for theta is where this is going to occur. Okay, and our next one then, 3 sine theta sine 72 minus 3 cos theta cos 72. So you notice the cos one, because it's got a cos and a sine, but it's not in the order that we want it, so we're going to need to change that round to minus 3 cos theta cos 72 plus 3 sine theta sine 72. Now we want to get rid of this minus 3, so we're going to factorise. And that should be in the brackets then cos theta cos 72. This becomes a minus then sine theta sine 72. So in our brackets now it's in the form cos cos sine sine. So we know it's going to be cos. Remember, with cos, it's always the opposite sign. Okay, so our maximum value of this is going to be 3, and it will occur when our cos of theta plus 72 equals minus 1. Okay, so remember this part here can go between minus 1 and 1. So when this is minus 1 times minus 3 will give you a maximum value of 3. So inverse cos of minus 1 is 180. So a value of 108 for theta will make this cos of 180 equal minus 1 and give us the maximum value up here.